Back over here, and this is the 2003 AIME 2 problem 9. And here's a view of this problem. Consider the polynomials p of x is equal to this, q of x is equal to this, and these are the roots. And then we want to find this. Just extend that line. Okay, so if we want to find, so z1, z2, z3, and z4 are the roots of q of x. So if we want to find p of these roots, it's a good idea to determine the relationship between p of x and q of x, and the best way to do that is by long dividing the polynomials, right? So we have x to the sixth minus x to the fifth minus x cubed minus x squared minus x, and we want to divide this by x to the fourth minus x cubed minus x squared minus 1. Okay, to do this, okay, multiply x squared. This gives us x to the sixth minus x to the fifth minus x to the fourth minus x squared. Subtracting this gives us x to the fourth minus x cubed, and then we need to bring down the negative x. Let me just make sure I did that correct. Minus x squared. Okay, it looks good. And then now what we need to do is we need to add 1, right? Adding 1 gives us x to the fourth minus x cubed minus x squared minus 1. Subtracting off gives us x squared minus x plus 1. Okay, so we've determined that relation, kind of. So p of x is equal to x squared plus 1 times q of x and then plus x squared minus x plus 1. Now it's the remainder we really care about, right? Because when we plug in pz1, pz2, pz3, and pz4, we're having this q term multiplied with this, so this will go to 0. So what we need to find is the summation from 1 to 4 of this thing. We can write that using compact summation notation, but I think it's pretty clear. So we'll just do z1 squared plus z2 squared all the way until probably z4 squared. Okay, minus the sum z1 plus z2 plus dot plus z4. And then we're going to have to add 1 how many times? 4 times, right? Okay, how are we going to do this? Okay, so the sum of the roots, what's the sum of the roots? z1, z2, z3, z4. By Vieta, they are 1. This is 1. So how about this thing now? This is just z1 plus z2 plus z3 plus z4 squared. Squared minus the pairwise Vieta, right? Okay, so sum of the roots, as we discussed, is sum of the roots, as we discussed, was 1. So 1 minus the pairwise Vieta. Pairwise Vieta is negative b by a, c by a, negative 1. So, and then it's 2 times the pairwise Vieta. Yep, 2 times negative 1. This is 3. So this is 4 minus 1 plus 4, or 7. And we are done. Does that look right? Yeah, we are done. I mean, this is 6, and we're done.